Welcome to a demo of a configurable recommendation system built with RAG. My name is Jonathan Skeet. I have 10 years of AI solution deployment. 5 years I've been hands-on with machine learning algorithms and infrastructure. I've had 3 years of engineering management capacity, and I've had 5 years as a full stack developer and also functioning as a project manager as well. And I've worked in various industries and various companies, including enterprises and startups, and the tire and rubber industry, and media and marketing, as well as SaaS. And for today's recording, we're going to go into details relating to the environment and experience, which are items that fulfill the capstone project for the interview Kickstart GenAI Edge Up program, which I'm a participant in. And so this is a continuation. The previous recording, we showed this same application, but only being able to be applied to a fitness product recommendation situation. In this case, we're going to show that same system with the same architecture, same infrastructure, be able to recommend not only for fitness products, but also recommend the best job applicants based on a particular job application or job description, I should say. And of course, still built on LLM foundation models. We're going to see, again, deployed locally here, the Llama 3 1.2b model responding to a prompt. See how long that takes, see how well it does at following instructions, and then we'll compare that to the OpenAI, the O4 mini model that was created on April 16th of 2025. And so again, previously when we looked at our recommender, it was only capable of recommending fitness products based on users' fitness goals. Now it's configurable based on being able to provide a variable set of instructions. Of course, in order to do any sort of RAG, it is necessary to set up a vector database first. So behind the scenes, we have set up a vector database for our products for fitness, as well as vector databases for lists of job applicants, right? So there is some behind the scenes work necessary to make this happen besides the user interaction, right? But again, at least the UI is prepared to handle these different sets of use cases. And so just some of the things that are going to make this experience a little different than the last one is one, the chunking system has changed. Again, here, this is where we do all of the addition of specific documents to our index or vector database. We don't need to do that because that takes it can take hours, but it's done ahead of time. But we can still inspect our index here, right? The important thing is that the dimension for the embedding vector in our index is set to 3072. So that way, when we do our similarity search, we know that when we embed our prompts, we'll use that same length vector so that the similarity search can occur. And then we can also check to see just how much information, how many documents do we have in our vector database, right? So we can see 974 job applicants in our OpenAI database, vector database, 975 in our nomic vector database. So one didn't make to OpenAI database, and that's totally fine. And then let's just take a look at our sporting goods just to see. In our Llama vector database, we have 972 sporting goods. OpenAI vector database has 972. So those are exactly the same. So that's good news. And again, the things that have changed, besides just the ability to reconfigure, we've made the chunk sizes smaller. Previously, we were chunking our documents that we sent to our index so that they would all just fit the limit when sent to our prompt, our embedding model. But we're trying to get a little better filtering. So now we've chunked our documents so that every chunk represents a single product or a single job applicant in our index. And so we'll see what sort of performance we get with this new chunking layout. Now what we can see, the difference here is our users can make a few more selections, which allows this to be configurable, right? Of course, like we said, the vector database needs to be there ahead of time, so they can select which vector database will be used for vector search. They can choose which sort of model set to embed and prompt. So we want to use our OpenAI model so we can see how quickly those perform. We're going to select our job applicant use case so we can see how well this same architecture can switch use cases and how easy that is to accomplish. And again, we want to prompt that O4 mini model so that that can generate the response for us, right? And so what I'll do, I already have a prompt here ready to go, and I'll put that prompt in. And the questions we want to see is how long does it take, how good is it at following instructions, right? And won't worry about the alerts that we're getting here, as long as we get our response here. But again, we can take a look here at our queue worker, make sure things are moving along as expected, right? Okay, and we got our response back, right? First thing I want to do is take a look and see how long did it take to get our response, right? So we got our response back at 2:52 and 29 seconds, and we sent our request for that response at, I'm pretty sure this will be 2:52 and 14 seconds. So basically it took us 15 seconds to get our response back. So that's great. Actually, we've been seeing, 5 minutes with our locally deployed Llama model, so that's way better. And we can we can see here in our list when response was requested and then how long it took to come back. So 14 seconds is when it was requested, 29 is when it came back, so about 15 seconds. So we're seeing amazing improvement there on the time already, just using the OpenAI models as opposed to locally deployed. And again, now let's see how great it was at following instructions. We said respond in less than 300 words. Pretty sure we said that, yeah, right here. And so let's check here how many words we got. 233, so that's great, much less than 300. And then let's see if we got good descriptions of why these are good candidates, and make sure that there's actually in the set of applicants that we have. So these look like the names of applicants that would be in this data set, so I'm happy to see that. And yeah, we can see here they're in some of those applicant listings, so that's great. So now let's see why would Eager Quail make a good automotive hood technician. Let's see, it says they know how to troubleshoot, they know safety protocols, and they're familiar with mechanical parts. That makes sense. Let's check the Charlottesville candidate. Let's see, senior software and robotics engineer. They've built hardware, led precision assembly teams. Their skills can be easily applied to vehicle inspections and fluid level checks. So that all makes great sense. So we can see it's doing a good job of reasoning and understanding what skills are transferable, and experience and education and background, right? So again, that was running with our OpenAI model, which we saw took about 15 seconds, which is great. Now we're going to try locally doing the same thing just to see how much different it is with a smaller model that's deployed locally, right? So because it's a smaller model, I expect the reasoning to be not quite as good. And because it's locally deployed, we don't have as much resource. I expect the prompt to take a bit longer, right? So one thing I want to do is get rid of this. We didn't actually embed that prompt live because I had already sent it, but we will embed this next prompt because it's free. I don't want to have to pay to to embed the same prompt twice. And so that's why that first time I just loaded one that was there already. So just give me 1 second here to build my containers very quickly, and then I'll redeploy. So basically just restarting my backend service and my message queue worker. So they'll run with a new set of code. Okay, so now all that's back up. And what I will do is just choose a different index right now. This time I'm going to use the OLLama nomic embeddings. So again, now we have smaller embeddings, right? So again, that's why I think the reasoning will be affected. And we're using the locally deployed model. So I think that's why we're going to see this take a little bit longer. So we'll use the exact same prompt. And we'll go ahead and send that. And I know we're going to have to wait a little bit. So while we're waiting, let's go ahead and just check out our architecture again. And again, the really cool thing about this is that we're using the exact same architecture that we used previously. It's just now that we've added a little bit of configuration to the UI. So now we can easily adjust and use this same system for various use cases, right? So we know we can, with a list of fitness products, ask our model to find products that would be useful to help us reach a specific fitness goal. And now we've seen that we can, with a list of job applicants, ask our model which applicants are best fit for a specific job, right? And again, this just all relies on our basically here application server being able to send jobs to a message queue, and those jobs in the message queue will contain a prompt which needs to be embedded. We've seen that we can not only prompt with OLLama locally, we can prompt with models deployed, models served over the internet. And then once we get that embedding for our prompt, we need to, using one of the vector databases that's already created, do a k-nearest neighbor search, get back a set of documents, and we share those documents with our model that's going to generate the response, just to describe what about each of the documents that were retrieved make it fitting for the response. So in the case of a fitness product recommender, it's why are these products helpful towards reaching a fitness goal. In the case of the job applicants, it's why does this job applicant make a good candidate for a specific job, right? And so once we get our response, we put that in the database so we can just have some chat history. And then we also are returning the response to the UI for the user, right? So again, same architecture for multiple use cases, which is really great. And looks like we're still waiting on the response here. Okay, so as we can see, our locally deployed model took much longer to respond. We sent our response at 3:06 and 2 seconds and got our response back at 3:08 and 12 seconds. So it took about 2 minutes and 10 seconds. So 2 minutes longer almost than our OpenAI model, even though this one's deployed locally and that one's on the internet. But again, that one's much larger, and the embeddings that we were able to provide are a larger set of embeddings because the embedding model was also larger. So we see the advantages, although prompting the model, the OpenAI model, does come at a cost. It can save a lot of time and make it worth the cost, especially in real e-commerce situations. And so again, now we've seen our original use case again with this new architecture. Again, we can see, I'm not even going to check, but I know somehow the OLLama model is not as good at following instructions, because I told it to make sure to use the list of candidates that was provided, but I know these candidates are not on there because there's no one named Emily or Mike or David. They all have funny names. And so this is probably, referring to some context that it gained during its original training, which, is why we rely on foundational models. But again, making better foundational models means that it will rely on the context that you provided, right? So again, that's the job applicant use case, which is a new use case. So now let's take a look at our original use case and just see how things perform with those indexes with this new architecture, right? So again, first I'll send a prompt to the OpenAI model. Let me get one that was previously sent. There we go. Of course, I have prompted this before, but we'll see what it does this time. It usually gives you different answers every time, even if you use the same prompts. Okay, so we're gonna say recommend 5 fitness products that can function as safety equipment, describe how it can be used and what benefits it provides, let's say in regards to safety specifically. Let's say respond with less than 300 words. I'll go ahead and send that off. And then again, in regards to following directions, let's see how well our llama model did in terms of keeping it under 300. Well, it did do that, so that's good news, because usually it responds with more than 300 words. So that's good news. And we got our response back again from our OpenAI model. And let's see how long that took again. So got our response back at 3:12, and we sent it at 3:11, 47 seconds. So it took 13 seconds. So even faster this one than the job applicant one. Probably because the prompt's a lot smaller. There's no job description here. And so weightlifting belt, it just tells us to use that. But let's see if that is in our listings. We do have weightlifting belts. It would be nice if it suggested a specific weightlifting belt, but at least it does recommend things that are possible to buy. Let's say in this marketplace, right? Let's see, knee sleeves. We do have knee sleeves. Okay, again, would be nice if it were to just give us a specific product, but this is good. This is actually great, at following instructions. I didn't tell it in this one to make sure to use stuff that's in the list, but I'm sure if I did, it would make sure all of these were there. And we'll go ahead and send another prompt and make sure and do that, because this one comes back so quickly. All right, be sure to only refer to equipment included in the context after instructions. Okay, we'll send that off. Oh, I have to select a vector database. I have some nice alerts here. And this is for sporting goods. OpenAI. Okay. All right, one more here, and then we'll do the next one. We'll do Llama just to see how much different the response is there. So we just saw the response after embedding. So embedding takes a second, and now we're getting our response. Got our response. Let's see how fast again. 1425 to come back. That one only took 11 seconds. So amazing. Somehow we're getting better and better. Barbell collars. Safety spotter arms. Let's see if that's in here. So it's not using the documents that are provided as context fully. So that is something that could be fixed somehow with some prompt engineering, I'm sure. But as we saw, it did pick things from the list, like product types, just not specific products, right? But again, it's still coming back really fast. So we're seeing some of the optimizations play out. And again, still using that same architecture that we were able to use for our job applicants with minimal changes, as we saw, mostly in the UI. And now what we'll do is just one more time prompt our llama model just to see how much worse it is, because we know the OpenAI models definitely perform better because they're bigger and they have a lot more embeddings to work with, a lot more to consider as they are reasoning, right? And again, let's just check. I mean, we can tell just from looking at these that they're less than 300 words. So I'm sure that's working out. Yep, 268 on that one. I mean, I'm just assuming because the 210, the bubbles are pretty small, right? But yeah, so we'll see how long it takes to get this last one back from Nomic and see how well it does. But again, now we're seeing just the ability to handle multiple RAG use cases, right? With the same architecture. It's very powerful. Okay, and we got our response back. Let's see how long that one took. So that response came back at 3:17 and 15 seconds, and we requested it at 3:15 and 57 seconds. So it took about a minute and 18 seconds, which is fast for Llama, but as we can see, compared to our OpenAI model, much slower. So we definitely know we want to use the OpenAI model in production. In terms of the products, I can tell again it's generalizing and giving us product types that we might find in the listing. It did keep it under 300 words, so it followed that instruction well. But I do not believe this is a specific product, or these are specific products in our listing. So again, a little bit of optimization that could be had here. But again, we'd most likely start optimizing first with our OpenAI model, since that's already giving us the best performance, and then we'd work from there. But yeah, this stuff is obviously geared towards safety. I don't even have to read how it would be used. Sometimes it tells you stuff that is kind of ambiguous, and that's why you want it to describe how it can actually help you with safety. But I can, again, just tell that the search is even happening better just because the responses that we're getting are a little bit better. It's just that we need to make sure it's only considering items in our inventory, right, or in our marketplace. But yeah, again, we did see the optimizations I intended to show today. Again, just the speed from querying online models, just how much better, let's say, suggestions we're getting based on our chunking, and better reasoning because our models have more specific data to work with as they're generating the suggestions, right? We've seen the updated chat configuration, also updated index tools, just allowing us to basically be agile with this deployment using the same architecture and addressing various use cases, right? And so this has been the updated demo here of the configurable recommender. Looking forward to continue working with LLMs, Retrieval Augmented Generation in specific, working with vector databases and other infrastructure, optimizing user experiences, and limiting and reducing costs in terms of time and money, while making an impact using the amazing AI tools at our fingertips. Thanks for watching. Hope it was informative, and until next time.